Today we're going to do a set I've never seen in the flesh before, and that's the Danita Mark III. We've done the Danita Mark II here. These were CPT only FM set. Sometimes you see one which purports to be 2781, but they're fake. So there we go. I've not seen one. Certainly different. I hope the customer knows this is CPT FM only. First of October. Mark 5, isn't it? Yeah. 1274. I think they're made by Maxon. My screw pot's right on top of one of the 4 microphones. There'll be a left-hand channel pop. The first thing I notice is the power connector's damaged. One of the connections is missing. Now, it may be this requires 3 connections. Maybe it doesn't. And will the chassis be like anything else that we've ever seen before? So it doesn't need the connection which is missing. That capacitor is knackered. You see if we can zoom in. Just going to unsolder the speaker. I've not read the customer's notes on this yet. Well, I have once, but that was 10 days ago. So, if we can kind of get that on a bit of an angle, it's actually bulging. Instead of being totally flat, it's got a bulge in it. So it looks like we have a crystal filter there. Transmitter lineups there, receivers there. I'll have a look online and see if there's anything that I can find, but it certainly looks like it's a Maxon chassis. So for less than £1, it's always sensible to change capacitors like that. I expect that's in the smoothing part of the circuit. As power goes in. I mean, without getting a magnifying glass, that it looks great. I'm always feeling for sharp bits around there, which can be detrimental to the transfer of power to the output socket. Right, we'll get this unsoldered. I think I can spot where it is. got another early version Amstrad 901 coming with an Action Man mic. Bear in mind those Action Man mics were withdrawn. You'd never expect them to work properly. It's nice to have, but use a different mic. Right. So it's supposed to be 1000 microfarads at 16 volts. So to do that, it's had greater than 16 volts applied to the radio. My ESR meter isn't on here. I think it's gone to Chippyville. Have we got any capacitors in this room? The answer is no. I'll go and get one. Right, I'm back with you. We have on file the original instructions book, which I've just printed out. Some novel design. High-low power. I don't think I've ever seen that on a CPT set before. And it's like the UK with 0.4 watt. Wow. I will be able to do a low power test. Got a layout. I can make head and tail of which way around it is. It's that way, isn't it? And then we've got circuit diagrams right and left. Right, we'll go through what it's doing. I've got to go out on business. We should get this. I would expect this works. It's 5-pin DIN, so we're going to expect it to be max on. Oh, we're not. We've got the Danita mic. Still expect it to be max on. We'll connect it up with our crocodile clip leads because we can. And let's get the PA speaker. We've got an S meter socket on the back, and it's 3.5mm. Normally they're 2.5mm. Right, we're on 13.8, and we're powered up. And it's in PA. Well, while it's in PA, let's play with the mic gain. I expect that's what that's on. Testing 1 2, testing 1 2, 1 2, 1 2, 1 2, 1 2, 1. Which is it? So that ticks off the mic, and ticks off PA, and ticks off meter lamp. So now it's all lit up like a Christmas tree. Yeah. Filter will be a tone control. It is. RF, that will switch RF gain on. Right, we're now to set up the test gear for CPT because we're normally set up for UK. So first of all, we're going to transmit. Switch picture in picture on. You know what? We'll plug the equipment aerial in. Ooh, 100 milliwatts? What's that about? He ain't a happy bunny. So, on we are doing, let's get this right, we're doing on the 3-watt scale, so we are doing 120 milliwatts. Let's see whether this is dependent on channel. 100 milliwatts on 40, 120 on channel 1. I can't read low power at the moment. I tried. Let's go back to 20. Put it on low power. Oh, it locked eventually. Did lock eventually. Transmit current 569 milliamps. Mind you, it's 401 with nothing on receive. Deviation, we're going to have to retune the test set. Wow, it looks to be 2.2, but we'll do that properly later. Frequency. (27.20482), not that far off. 27.20482. So with that in mind, we'll set the signal generator the same, 27. To not quite put 205, we'll do it the same, 20482. Okay. Let's go over to the synod meter. Switch that on. So it proves the aerial part's working. Because sometimes you think, you've got low power and transmit, is it not all getting out of the aerial? Well, the fact that the receive's working very well, it's doing 0.31, 0.26, and for 20 dB, it is between scales. I'm between scales here. It says 1 on that scale, and it says 0.95. We'll say 1. So, in view of that working properly, we'll check the squelch out. Squelch to full on the radio. Let's put the attenuator up on the screen. I want it to be 100 microvolts when it comes in. Comes in at 2.5, no, 8.2 millivolts, which is too tight. And on the sensitive end, let's put that to standby, reset the squelch to threshold. It's 0.3. Alright, meters. So the S meter should read 100 microvolts for S9, and it is very, very generous, and it is reading 7.2 for S9. So it should be 100. Don't confuse this with amateur radio, which is 50 microvolts on HF. Right, transmit. See what the meter reads. Well, what you'd expect, not a lot. I won't put that down because the radio's not transmitting properly. So we'll just see if it's a tuning problem, and then I'll disappear off. If it isn't a tuning problem and it's got a fault, we're soon to find out. Just turn the volume down. We'll put the right meter up as well for you. So there we are on the 3 watt scale. We're on channel 20 and just over 100 milliwatts. It's been the centre of the peak, not just the peak. I can't find a coil in there. The fact it's filled with wax tells me there should be one. There is, but I think it's long since broken. Right, we'll take that coil out. I think it's these. Where's the solder wick? I think we're going to need it for this. See whether that's moving at all. The answer's not yet. I'll do this off video. Right, we're day 2 on this, and we've got to pack this away because there's another customer repair which has to be done tomorrow. I've had to do the accounts today, so we've only got 40 minutes to put into this one. So we're just going to do 1 or 2 more things. I've got a very poor circuit diagram here. So if any of you have got a better copy of this circuit diagram, because it's like a photocopy of a photocopy of a photocopy, I can't read where things are going. All I can see is squiggly lines. So anyone wants to email me a Danita Mk5 circuit diagram, it would be greatly appreciated. So, I mean, normally we have instruction books. If they're in the instruction book, then we can do a first generation high quality scan, but it's not in the instruction book, so we're scuppered. So it's a Maxon chassis. It isn't the same as the Midland 77-250K Power Max, it is not the same, although it's still a Maxon chassis. This looks actually better than that. So we can't get this high-low. There's a problem with the high-low power. I've done dry joints and I thought, oh, that's going to be it, but it isn't it. So we've got, this is 0.4 and 4 watts as I figure, these two presets, but it doesn't matter where you put them, you're still going to get 100 milliwatts, so nothing's going through. So the voltage regulator circuit has got a problem, but how that works I can't tell without a circuit diagram, and that's as much use as a chocolate teapot. So what we will do, just to progress with this set, is we'll go through the receiver, just check it's on frequency for a start. I'll just put the other camera on, or the system on actually, and then we can select picture in picture with any look. There we are. So let's do the detector. So we've got S9 on the signal generator. Oh, we'll just check it's on frequency first. We'll go to the frequency counter. 27,20481. So we'll just bring that up. That'll do. So we'll just see where we are on our signal generator, 205. That'll do nicely. Right, detector. Let's go to the oscilloscope. That looks to be the detector. But you know what? It isn't. That one looks to be the detector. Wow. Miles out. Right, we'll go over to the cyanide meter now. Now, because I upset that IF coil, but we'll do that first. I'll go through the front end. That was spot on. Bigger signal. I think we're about there. There are a couple of broken cores, but they're not affecting what we're able to do. In other words, they're still moving, they're not jamming or anything. Let's see what we've got now. Now, because I've done the detector, it could be totally different. .32 for 12 dB. Oh, where's my sheet? Yeah. $10 dB. 0.28. Again, we're between 1.2. So you can see it's very slightly worse, but the detector's right now. So it won't sound garbled anymore. Let's see if we can sort the squelch out. And that's what will have been what was affecting the squelch, the detector. But it's a full squelch. Straight in at 100 microvolts. Let's put the attenuator on to show you. It's exactly where it should be. If it wasn't exactly where it should be, the squelch preset is this one there. So that's come right simply by doing the detector. Right, let's do the sensitivity. .56. The meter for S9. So it was not right before. It's spot on now. Again, the detector's sorted that out. The S meter is the preset just there, the lower one of those two. That's now right. Can't do anything about the RF meter because no RF. I could do deviation, but I won't bother. So that's where we got. We're going to have to abandon this, come back to it another day. So we're still on 100 milliwatts of transmit. Just to remind you. And the issue is with this high-low power voltage regular arrangement. I don't think I've had the transistors out, I've had the driver out, I've had the output transistor out. They read right, so that was barking up the wrong tree. So hopefully we'll get a better circuit diagram and then we can progress with it. So a set that's not finished. It's going to be Realistic 1001 again tomorrow, different set. And thank you for watching the beginnings of sorting out the Danita Mk5 from about 1987.